Welcome to the lesson on production planning and control. Upon completion of this lesson, learners will be able to analyze the importance of production planning for manufacturing, formulate a manufacturing plan utilizing the 5 key elements of planning, and explain how workflow affects manufacturing production. Learners will also be able to discuss proactive planning and planning tools, as well as facility workflow, capacity, and scheduling. The manufacturing world is very competitive and involved. Efficient and effective planning is very important if you wish to be successful. Planning of such complex systems can often be decomposed into smaller subplans. To be efficient, a manufacturing production system requires proactive planning, an appropriate facility layout, adequate transfer systems, and a knowledge of what the intended production capacity should be. Planning, in general, is a required tool to anticipate and prepare for future demands. The production planning department of a company is responsible for ensuring that production goals are reached with minimal cost and time. The primary purpose of production planning for a firm is to meet the client's demands while maintaining a stable workforce. This benefits the firm as meeting customer demands translates to goodwill and customer loyalty. Production planning affects many of an organization's functions as it works to coordinate several functions within the company. Therefore, production planning provides management with the necessary tools for establishing strong communication links between the organization's departments and assisting in making decisions about production activities. In most instances, being proactive is synonymous with planning. But then, what is proactive planning? Proactive planning refers to the strategies used in problem solving and in situation preparedness. Usually, it involves the description of a desired state and the creation of processes to achieve the defined goal. However, in some companies, proactive planning refers more specifically to their ability to respond to production emergencies, such as a sharp and unexpected inflation of customer demand. An example of such proactive planning would be the reorganization of certain employees to increase the personnel's capacity to perform in periods of stress. Proactive planning can thus be considered a preventative measure that allows the organization to identify the elements to control in order to reach its production-related objectives. Production planning involves coordinating activities from different departments in the company. Manufacturing planning typically involves forecasting market demands based on historical demand data and analysis of market trends, controlling inventory to reliably estimate levels and schedule orders, accordingly, ensuring availability of equipment and human resources to meet customer demands, standardizing the steps and time essential to production processes through process mapping to observe the order of production processes, and evaluating risks to minimize or eliminate them. Because these planning activities require resources from many different departments, the planning process is considered to be a cross-functional endeavor, and accurate and timely communication takes on an increased importance. Cross-functional activities can be overwhelming, but if you and your team use this interdepartmental communication to your advantage, you will improve the workings of the company. Cross-functional teams help you to better anticipate demand, coordinate resources such as people, tools, and equipment, prioritize goals, and serve other company functions cohesively. As noted earlier, production planning requires effective data management. To meet this need, a variety of planning tools have been created over the years. The documentation involved with these planning tools helps make setup procedures repeatable. These planning tools include, but are not limited to, flowcharts, Gantt charts, advanced planning and scheduling, master production schedules, and the material requirement planning method. Let us look into each one of these in detail in the upcoming slides. Flowcharts provide detailed visual representations of each step in a process, helping to identify and streamline workflows by mapping out the sequence of actions. They are particularly useful for pinpointing potential bottlenecks and areas for improvement within a process. Gantt charts, on the other hand, are primarily used for scheduling and tracking project timelines. They display the time required to complete a sequence of tasks, typically including start and end dates. By providing a visual timeline for task dependencies and deadlines, Gantt charts help manage resources effectively and ensure projects stay on track. Advanced planning and scheduling, abbreviated as APS, is a method used to optimize the utilization of all manufacturing resources in a finite capacity plan. Specific optimization goals, such as minimizing time or maximizing throughput, can be inputted into an APS system. Master production schedules, abbreviated as MPS, are documents in which manufacturing production is organized and planned depending on the monthly demand for products. An MPS can either be done manually or can be generated by a computer. The MPS keeps all workers informed of deadlines and other production demands. It is an effective recording tool that helps workflow. An example of a master production schedule can be seen on this slide. The master schedule takes into consideration all the time factors that are relevant to the production, from the waiting time or lead time, that is the time it takes to receive orders from suppliers, to the time it takes for products to undergo quality testing. This schedule is usually stable over a 6-week period, but changes in demands or supplier characteristics might induce related modifications to the production schedule. All team members should be notified of schedule changes as soon as possible. Finally, no matter the changes that may occur, the master schedule should always fit within the plant's capacity. Computerized planning systems, such as Material Requirement Planning, abbreviated as MRP, are used to manage the firm's resources according to a generated schedule. The main objective of Material Requirement Planning is to make production as efficient as possible with the company's given resources. Typically, in an effort to optimize resource utilization, production lines and plant layouts are designed to quickly process products with minimal downtime. Realistically, to achieve a smooth flow of work with minimal downtime, differences in labor and equipment times and material requirements across products should not be too large. However, these conditions are not sufficient to guarantee efficiency. When planning for efficient workflow, there are several additional factors to be considered, including the movement of the required materials, plant capacity, the layout of the equipment and facilities, and the production schedule. We will discuss each of these factors in detail in the upcoming slides. Work material can be moved between stations either manually or mechanically. Manual transport is usually associated with assembly lines and can involve a large amount of in-process inventory. This method allows for little control over the production rate on the line. On the other hand, mechanized means of transport in the production line can be classified based on the transport system used in the production line. They can be classified as continuous, synchronous, or intermittent transfer systems and asynchronous transfer systems. The 3 types of transfer systems are explained in this table. Continuous transfer systems move material at a constant velocity, as seen in conveyor belts transporting tires. Intermittent transfer systems move materials simultaneously between stations in quick, irregular motions, such as robotic arms operating between welding stations. Asynchronous transfer systems, which can be either manual or automated, move each unit of the product only when needed, like EV motors moving between test stations as each test completes. A company's plant capacity, or production capacity, is defined as the maximum quantity of products that the plant can output under normal operating conditions in a given time frame. To align the plant capacity with the desired master schedule, changes can be made to the plant workings. Changes in plant capacity can be made through either short-term or long-term alterations. Some short-term changes include the number of employees working or the length or number of their shifts. Short-term capacity changes also include subcontracting. Some long-term capacity changes can be achieved through the purchase of new equipment, investment in additional production space, or even closing plants not needed in the future. These adjustments help fulfill the needs of the business and the customer. In manufacturing, the term facilities refers to the equipment, including material handling equipment and their arrangement in the plant. The layout of the plant and locations of the equipment, labeled facility layout, are important to ensure an efficient flow of work from one process to the next. Each layout sets up equipment a little differently. There are 3 main types of facility layouts based on the size and ease of transfer of the material being treated. They are product layout, process layout, and fixed position layout. A product layout, such as an assembly line, has large amounts of products that are moved sequentially through the different workstations at which specific tasks will be performed. A process layout, mainly used for irregular production, groups similar processes together into workstations. For each process, such as cutting, milling, or dyeing, the material will go through one workstation and be entirely processed there before it moves to the next. A fixed position layout is used for manufacturing very large products in low volumes, such as ships. This is the only type of layout in which the product sits in one location from the early stages to completion, and all the equipment and workers gravitate around it as needed. When planning production, the company should determine what parts or products are being produced, number of parts of each type, the process of production, and the timing of production. This information, along with a list of products and quantities, will be incorporated in the aggregate schedule, also referred to as the master production schedule or master schedule. Some suggestions for achieving a successful team-based production schedule include efficient workflow and use of time, appropriate match of workers' skills with scheduled production steps, effective implementation of schedule by all workers, timely notifications of schedule updates, and consistent collaboration between all team members to solve problems. When building a production schedule, it is important to determine what you are making, what steps you will take to make it, and how long it will take. This schedule optimizes the utilization of both time and effort. The effort from the workers should not be wasted on tasks that are unrelated to their skill sets or talents. Before and during planning, workers with skills should be placed intentionally according to production needs. In summary, production planning is important for manufacturing systems companies to anticipate and prepare for future product demands. Proactive planning helps companies solve problems and prepare for unexpected situations, such as a sudden increase in demand. The key elements involved in manufacturing planning include forecasting, controlling inventory, optimizing resource usage, standardizing steps, and evaluating risks. Lastly, a company's workflow and efficiency are affected by the facility's layout, material movement, the capacity of the plant, and the overall production schedule. Thank you.